Hello everyone, this is Abhishek Datta and you all are watching my YouTube channel Mathematics Made Easy. Today in this video, we are here to discuss about two very important and vital topics of calculus, that is relations and functions. Without the proper understanding of these two topics, it is not possible to grasp the deeper concepts of calculus. So without any further delay, let us start the discussion. Now, before giving you the definition of a relation or a function, let me in short explain the concept of the Cartesian product of two sets. So I assume that my viewers all have the basic concept of a set. What we mean by a set, that is, a set is a collection of well-defined and distinct objects. That is the idea of a gathering or the idea of a collection of some objects. Those are well defined as well as distinct. Such a collection we call a set. Now, how to multiply two such sets? We know how to multiply two numbers. Let us now define how to multiply two sets, that is how to multiply two collections. This product is known as the Cartesian product. Now, to illustrate this, let me first take you to the whiteboard. So, let us consider two sets A and B. Let us consider two sets A and B. Say we have a set A consisting of three numbers 1, 2 and 3. So here we have a number set containing three elements 1, 2 and 3. This is the set A, and we again have a set B containing two alphabets, say A and B. So the first one is a number set, the second one is an alphabet set. First contains three members 1 to 3, the second contains two members A and B. Let us now try to multiply these two, that is to form the Cartesian product between two sets A and B. Now the product is commonly denoted by the symbol A cross B, the same notation as we use in operations of arithmetic. The same notation for product is also used to represent Cartesian product among two sets, that is A cross B. So here this is equal to the set A, that is 1, 2, 3 multiplied by the set B, A comma B. Now here the result is also a set, but this set has some specific properties. So first of all, when we multiply two sets, the result is also a set. Product of two collections also gives us a collection. Now here the members of this collection, the resultant collection, won't be single elements. Likewise we had for A and B, 1, 2, 3 single members. Here also A and B single members, but the members of their product A cross B will be ordered pairs. So what we mean by ordered pairs? So how we have to form the product? The rule is you associate every member of the first set. Say if we first consider the element 1, we associate 1 by 1 to every member of the set B. So first we associate 1 with A, we write this by 1 comma A within two first braces, and comma again 1 to B represented by 1 comma B. So these are the ordered pairs. Why paired? Because every member of A cross B has two members, two elements in them. This is one member of A cross B, this is another member of A cross B, and every member contains two elements. So they are paired members. And why ordering? Because positioning is important here. Instead of 1 comma A, if I write A comma 1, they will be treated as different pairs. So hence the name ordered pairs. Ordering means the position, which comes first, which comes second. Here the number comes first, the alphabet comes second, because in the cross product the number set occupies the first place, the alphabet set occupies the second place. So here while forming the ordered pairs, the members of the first set, that is the number set, are to occupy the first position, and the members of the second set, that is alphabet set, are to occupy the second position. So these are ordered pairs. So we have associated 1 to every member of B. Likewise, we can associate 2 with all members of B, that is we get another 2 ordered pairs, 2A, 2B, and likewise we associate 3 and we get 2 ordered pairs, 3A and 3B. So this completes the Cartesian product of A and B. So this is the Cartesian product of the two sets A and B. And you also note here that cardinality of the set A is 3. What is cardinality or cardinal number of a set? By cardinal number of a set, we mean the number of elements contained in the set. That is known as the cardinal number or cardinality of that set. So here cardinality of set A is 3 because it has 3 members. Cardinality of the set B is 2 because it has 2 members. So you note here that the cardinality of the cross product A cross B is 3 into 2, that is 6. So we have total 6 members here. So in general, if the set A has P elements and that set B has Q elements, then their Cartesian product A cross B shall contain P into Q number of elements. So this is how to multiply two sets A and B. Now let us try to define a relation from set A to set B. Let us now try to define a relation among these two sets from A to B. So to elaborate the idea of a relation, how to establish a relation between these two sets, let me now consider a subset of A cross B. So this is the A cross B. Let me now consider a subset of this. So what we mean by a subset? Subset means a sub portion. Subset of a set means a particular portion of the set. So let me now choose some definite pairs from A cross B. Say we form a set 1A, 1B and 3A. So it is a subset of A cross B. Let us represent this subset by R1, say R suffix 1. So this is a particular subset. Likewise, we can have other multiple subsets also. Say R2, another subset R2. So we choose a different combination now. Say I choose 1B, 2A, 2B. So this is another subset. So likewise, we can have many more subsets. Now each of these subsets R1, R2, R3, R4 and so on, each of these subsets defines a relation from the set A to the set B. So basically, by a relation from one set to another set, we mean a subset of their Cartesian product. So whenever we have to form a relation, we are to form a relation from A to B. First you form their entire Cartesian product and choose any one subset from it. So this subset will establish a relation among the two sets. Now let me elaborate the concept diagrammatically. That will be more easier for you to understand. Let me now draw this subset or draw the relation R1. So for that, let us draw that this circle represents the set A, this circle represents the set B. These are the members of A, 1, 2, 3. These are the elements of B, A and B. Now under the relation R1, as you can see here, 1 is associated to A. So we associate 1 to A by an arrow. This is known as arrow diagram. This type of diagram is known as arrow diagram because we show the association by such an arrow. So 1 is associated to A, 1 is also associated to B. So again we link 1 and B by another arrow. And 3 is associated to A. So 3 is linked to A. So this is the diagrammatic form of the relation R1. Likewise, we can also draw the relation R2. So here our sets A and B, members of A 1, 2, 3, members of B A and B. Under the relation R2, 1 is linked to B, 2 with A and 2 again linked to B. So this is another kind of relation. Likewise, we may have many more relations. Now, how many such relations can we have? How many such relations is possible to establish between A and B? Are the number of relations finite or are they infinite? The answer is the number of relations from a set A to a set B is given by 2 to the power cardinality of A, that is Na, multiplied by cardinality of B, that is Nb. So here Na is 3, cardinal number of A is 3, it has 3 elements. Cardinal number of B is 2, 2 elements. So 2 to the power 3 into 2, which is 2 to the power 6, which is equal to 64. So here we can have 64 such relations from one set to another set. So this is the rule to find the number of relations from one set to another set, 2 to the power product of the cardinality of those two sets. So here likewise R1, R2, R3, R4, R5 up to R64. 64 relations are possible from set A to set B. So basically what we mean by a relation from one set to another set, by a relation we mean that we are to associate some or all members of the first set to some or all members of the second set. As you can clearly see that it is not mandatory to associate every member of first set to every member of second set. It is not mandatory. You can associate also, but you may not. Likewise here, the member 2 of A has no association with any members of B. Here also the member 3 of the set A has no association to any member of B. So some members or all members of the first set can be linked to some members or all members of the second set. Again here also you can have extra members. So some or all members of the first set are linked to some or all members of the second set. So that establishes a relation among these two sets. And more formally speaking, any subset of their Cartesian product defines a relation from first set A to second set B. So these are nothing but subsets of A cross B. So basically by a relation between two sets A and B, we mean a subset, any subset of A cross B. Let us now define a function. What is a function? What is the basic difference between a relation and a function? Practically speaking, a function is nothing but a relation. It is a relation but with some restrictions imposed upon it. So every functions are relations, but every relations cannot be considered as a function. So what are the two restrictions imposed upon a relation to make it a function? So let me now illustrate a function with the same example of the sets A and B. So basically the basic idea is the same, that we are to again consider a subset of A cross B, because every functions are basically relations. So they are nothing but a subset of A cross B. But while choosing this subset, we are to follow two particular restrictions. Let me illustrate this in terms of a diagram. Say this is the set A, this is the set B, let us now consider such association: 1 with A, 2 with A and 3 with B, and let us represent such an association by the symbol F. So a function is commonly represented by F. So here basically it is a relation, because some or all members of the first set are associated to some or all members of the second set. So basically it is a relation. But here we have two vital restrictions. The first point is, here the first set, in case of a function, the first set is often termed as the domain set, and the second set is often termed as the codomain. These are the two terminologies we use in case of a function. In case of relation also you can use the same term, domain and codomain. The first set is termed to be the domain, the second one is codomain, but it is more frequently used in case of a function. And the elements of domain are termed as objects, and those elements of codomain to which these objects are associated, they are termed as images under this function. So here 1, 2, 3 are objects, A and B are the images. So image of 1 is A, image of 2 is also A, and image of 3 is B. So these are the objects, these are the images. Now here you see one thing, that all the objects of the domain are associated to some element in codomain. So this is the first criteria which differentiate a function with from a relation. That in a relation we can associate some members or all members of the first set to some or all members of the second set, whereas in a function every member of the domain set, that is the first set, has to be exhausted. We cannot have any member in domain, or we cannot have any object in domain which has no image in codomain. That is not allowed in case of a function. So the entire first set must be exhausted in case of a function, whereas in case of a relation there can be members in the first set which are not associated to any member of the second set, but in case of function it is not so. The entire domain set, all the members of domain set must have some sort of association with the codomain set. That is the first criteria. And the second criteria is one member of domain are to be uniquely associated with one member of codomain only. Uniquely associated. Uniquely means every member of domain must have only one and only one image in codomain, uniquely. Mind that different members of domain may have the same image. That is a separate thing. Different members may have the same image, but individually each of them have only one image. One has only one image individually. Individually 2 has only one image. Individually 3 has only one image. It doesn't matter if different objects have the same image, they can share same image, but individually they are to be linked with one member only. That is, I cannot link 1 to A and again I cannot link 1 to B. That is not a function. So that is the violation of the second rule. So if I draw another diagram here with the same sets A and B with elements as 1, 2, 3 and here elements as A and B. If I now associate 1 to A and again 1 to B and again 2 to B. So here you see, first of all, every member of domain are not exhausted because the element 3 in domain have no image in codomain. So this violates the first condition of a function. And also the second condition is one member of domain must be uniquely associated to a member of codomain. That is, every object must have one and only one image. Here 1 has got multiple images. One is linked to A, one is also linked to B. So it has got multiple images. So it is certainly a relation but not a function. So this is the vital differences between a relation and a function. A function is obviously a relation. Why? Because basically it is a subset of A cross B. If you have to represent this function in terms of a set, so how to represent a function in terms of a set? So here we have the ordered pair as 1 comma A because 1 is associated to A, then 2 comma A and 3 comma B. So this is the set representation of the function f. So basically it is nothing but a subset of A cross B. So it is also a relation because that is the basic definition of a relation. Any subset of A cross B defines a relation. So it is certainly a relation as well as a function also. Whereas here, if I call this say f and if I call this r, so if you denote this by the set theoretic approach, so this means the ordered pairs 1 comma A, 1 comma B, then 2 comma B. So it is also a subset of A cross B. So this again defines another relation. So this is also a relation, this is also a relation. But this relation cannot be considered as a function, whereas this is a function. So the two vital conditions of a function are that every member of domain must be associated to some member of domain of codomain, and one member of domain can be linked only to one member of codomain. One member cannot be linked to more than one member. We call it one-to-many association. That is not permissible in case of a function. Here, this type of association is known as one-to-many. One has multiple images. So one-to-many association, that is not permissible in case of a function. Many-to-one association is permissible, but one-to-many is not permissible. So this is what these two criteria differentiate a function from a relation. So from this discussion, we can conclude that every function are nothing but relations, but every relations cannot be considered to be a function unless they satisfy the two criteria. Now functions can be classified in different in 4 categories actually. In 4 categories we can classify these functions. One is into function and onto function. So what is an into function and onto function? By an onto function we mean that the range of a function. Let me first define what we mean by range of a function. Range means the set of all images, they constitute the range of the function. Likewise here we have a function f. So to denote the range of f, we write it as range f. So that is equal to the set of images, that is a and b. Images means all the members of codomain which are linked to some member of domain, they are the images. Now if I have multiple members in the codomain, say in the same diagram, if I add some multiple members C, D, E likewise, so they are not images. Why? Because they are not linked to any member of the domain. They have no association with any member of the domain. So only the members of codomain, that is in this case A and B, which have some association with the members of domain, they are termed as the images. And this is the set of image A comma B. So this set of images is known as the range set of the function f. So by range of a function we mean the set of images. Now as you see here that this set, image set, is a proper subset of the entire codomain. Proper subset means there are members in codomain which are not the member of this set. There are extra elements in codomain. So this set AB is a proper subset of codomain. It is entirely contained within the codomain. It is not equal to codomain. It is contained within the codomain. So it is a proper subset. So if the range of a function becomes a proper subset of codomain, then such a function is said to be an into function. Into function or into mapping. A function is also sometimes termed as a map. So it is an into function or an into mapping. Whereas by an onto function we mean that the range of the function is equal to the codomain itself. Likewise in our previous example, the codomain was AB and the range was also AB. So if the range set becomes exactly equal to codomain, then that function is said to be an onto function. So into function means the codomain has got some extra elements which are not the images under f, whereas onto function means the range set is equal to the codomain set itself. That is, all the members of codomain are also the images under the function f. So this is into function and onto function. Likewise, we have one and many one function. One function and many one function. By many one function we mean that more than one members of the domain are linked to one member of the codomain. So this is many to one association, many one function. Whereas if different functions of domain are linked to different elements of domain are linked to different elements of codomain, we call it a one-one mapping. Likewise, if I draw a diagram like this, this is our domain set A, this is our codomain set B. Domain set has 4 members, codomain set has say 5 members, and different members of domain, as you can see, are linked to different members of codomain. So this is a one kind of association, whereas this is a many one kind of association. So basically we can categorize a function into 4 types. One is into function, next one is onto function, next is one function, and next is many one function. So I shall discuss these 4 criteria, that is one function, many one function, into function and onto function in more details in my next video. In this video, my aim was to discuss the basic concepts of functions and relations and to differentiate between a function and a relation. Now we have many kinds of relations also, that is reflexive, transitive, symmetric. There are many kinds of relation as well as many kinds of functions. So we shall cover those in our next video. I hope this video is helpful to you. This video was intended only to make you understand the basic concept of a relation and a function, and we shall continue our discussion in the advanced field of functions and relations in our upcoming videos. If you have any queries or doubts, you can post in the comment section. I will try my best to answer them. And if you like the video, please try to like this video and subscribe to my channel. It will help my channel to grow, and we shall be meeting soon. I hope you All the best. Thank you all for watching this.